All right, so I got another little project here, and I mean, I always got projects, right? And as you can see, we got some brake rotors here, and well, there's no bolt pattern in these. So that's today's project. We gotta put a bolt pattern into these. Now here's our sample rotor. This is what was on his rear end, and for whatever reason, this isn't working for his application, and he needs these larger diameter holes. He needs that pattern put into his rotors. So he doesn't even know what his bolt pattern is. We need to figure this out. It's actually not that complicated. Now, we don't need exact numbers, just to figure what his pattern is. And we can just measure the diameter of this, and we got 0.718. And we're gonna take 0.718, we're gonna divide that by 2, and it's gonna give us 0.359. Now we can go and we can take a quick measurement of the spigot diameter here. And we get roughly 3.060, and we're going to divide that by 2 as well. 3.06 divided by 2, 1.53. Now we're going to go in here and we're just going to take a measurement from these two radiuses, and we get roughly 0.480. 0.480. Now we're going to add these three up here, so 0.480 plus 0.359 and 1.53. 1.53 plus 0.359 plus 0.48, and we get 2.369. We're going to multiply that by 2, and we get 4.738. Now that's not a real number for a bolt pattern, so we're just going to round up 12 thousandths, and we're just going to go with a 4 3/4 inch bolt pattern. So that'll be a 5 by 4 3/4. All right, here we go. So grade 7 math class coming up. Let's drop our rotor on our sheet of paper like this. Whoop. And let's trace out these 5 holes that we need. And that's roughly the center right there. Hopefully we see this. Now, this circle right here is our bolt circle, and we know that that was 4.75, and half of 4.75 is 2.375. We're going to need to know that. Now, the machine moves X and Y. Well, I guess it depends which way you're staring at this thing. So this would be X, this would be Y. That's the way the milling machine is going to move. So right off the bat, you can see that we would automatically be lined up for 1. And if we went off the center, we know that half our circle diameter, which is 2.375, is going to be there. So all these are going to be 2.375 away. Now we got 360 degrees, and we got 5 holes. So divided by 5, that's 72. This is a pretty common pattern for me. I got some of these numbers memorized because I actually do bolt patterns quite a bit. Trying to draw it out and talking, that's new. that's new. So bear with me here. Okay, so we know that it's 72 degrees between all these holes, and we know that these lines right here are 90 degrees from each other. And so the easiest way I think to do this, to show this, is let's draw, a right angle triangle. I guess this would be a left angle. This would have been the right, but whatever. Okay, so we know that this is 72, and we know this here is 90. And so if we take 90, subtract 72, we end up with 18. And that tells us that this right here is 18 degrees. Now we also know from the center here, the center of each hole is going to be 2 inch, 375. This is the hypotenuse to a right angle triangle. So we now have 2 bits of information for this triangle. And what we're trying to figure out is how far X and how far Y to move. So if we take 18 degrees sine, multiply that by our hypotenuse, 2.375. This is going to give us 0.7339. 0.7339. This is our side opposite of our angle. Now is all we need to do is our side adjacent. And there's a couple different ways you can do that. You can square the hypotenuse and subtract side opposite squared, and then find the square of that. That would give you this. You know, a squared subtract b squared will give you c squared kind of thing. That's the Pythagorean theorem. Or we can do a little more trig. We know that this is 90 degrees. We know that's 18. We can take 90, subtract our 18, which is going to give us 72 degrees right here. And we can take 72, we can tan that, and we can multiply that by, which is, you know, what was our side opposite is now our side adjacent. So 0.7339 equals 2.2587. There's our coordinates. If we move over 2.2587 and up 0.7339, there's that hole. That's also going to put us in this hole too. So this would be our x minus. If we went to x plus, that would be that hole right there. So 2 holes are figured out. Well, technically 3, because we know that this distance here is that number. So now all we got to do is figure out what this one here is. Now, the no-brainer would be, you know, we know that these are 72 degrees apart. Half of 72 is going to be 36. So that would be 36. Sometimes you just want to go by that. You actually want to do the math. Well, we know that these are 72. And we know that this was 18. So if we did 72 subtract 18, that would give us 54. So that's telling us that this distance here is 54. And if we did our 90 degrees, you know, right here, and subtract our 54 degrees, which is this distance, that's going to give us 36 degrees. So we know for certain that that's 36 degrees. And once again, we already know our hypotenuse is 2.375. And then we just do those same functions again. So, 36 sine times 2.375 is 1.3959. And we do the same thing again. We can do 90 subtract 36 equals 54. And so if we do 54 tan times 1.3959 equals 1.921. We're going to round that up to 3. And now if we move y this distance and x this distance, will put us in this location. So we've now got it all figured out, except I'm going to do one more little bit of math here. And this is going to save our butts down the road someday. Excuse me, and it actually has saved my butt. So if we take this number here, this 1.3959, I hope we can see that. So that number there. And if we multiplied that by 2, that's going to give us this distance right here. Not the radial distance, but the actual chord in between. So the distance between here is called the chord. So that's going to be 2.7918. So we'll just call that 2. 2.792. And is what that's going to do is if we set our dial here, where are we, 7.92. So if we set that up to this number here, and if we took our rotor, I'm going to go around, I'm going to spot these holes first, and then from my spot hole, I'm going to go like this, and I'm going to make sure they're the right distance. So if we take it and go to the edge of the hole, outside edge to outside edge, I mean, hoping we can see that in the camera, you can see that that lines right up. And if we go to this edge just like that, it lines up. And if we go to these two, you know, see that lines up. So that chord that we just did the math lines up. So when I spot these with my spot drill, before I actually start making any big holes in there, I'm actually just going to go, I'm just going to make sure that I get that correct chord spacing. And that's going to let me know if I screwed anything up. So there's our coordinates. I hope the scribbles made sense. Let's make some holes in this. So I got it clamped down. It's a pretty basic setup. So I got the rotor sitting up on some strapping just to keep it from getting marked up from my table. We got a pair of clamps holding it down. We got a little bit of aluminum in there just trying to keep it from beating up. I got 2 rounds placed here, and those are there. I'm just hoping for repeatability when I put the next one up in here. I'm hoping we're going to be pretty close to the same location. And I've gone around and I've dialed up center to the bore and got my readout zeroed out. Now we're just going to go around and we're going to spot the 5 holes. So I'm going to start off with this nice carbide spot drill. And going by our drawing, we're going to move to our first hole location, which is 2.375 on the X. And we're going to give that a little spot. Just like that. Then we're going to go to our next location. And just like that, we spotted all 5 holes. Now we show up with our calipers and we got our chord distance that we figured out set. I can go and see that the hole spacing or the chord is correct. And that we indeed got these in the correct spot. And we got all these holes pilot drilled now. Now for our final drill size, it's a 23/30 seconds, and I only got these in taper shank drills, but I got an R8 to taper shank adapter for the Bridgeport. So we just fit that in there. And there we go, just like that. We got 5 holes in the right location. In the end, my setup worked out to be within 3 on the X and 1 and 4 on the Y, just by a couple of these little stops like that. All right, so there's our 5 holes. And if we take our sample rotor here, we line its holes up. Hoping we can see that. Let's look at that. I'm gonna say we got those in the right spot. We can do the same. We can check both these rotors to each other, and I'm going to say that worked out to plan. Now these are generally quick and easy for me to do, especially when I'm not dragging around the camera or trying to do little math lessons. So that being said, I made one hell of a mess here today. I cut a lot of material here today, just beside these 2 holes. So I'm going to get cleaning up and I'm going to go home eat dinner. So thanks for tuning in, everyone, and I'll catch you later.